Good day, everyone. Welcome to my presentation about spatial analysis. I'm going to show you something about how to learn about your client's behavior using two approaches, using Azure Spatial Analysis and some hardware-supported analysis. My name is Krzysztof Nogieć. I am a machine learning AI architect at ANEGIS, a Microsoft partner. I am specializing in Azure Cognitive Services, Big Data Analytics. I am pretty much enthusiast of computer vision, and whenever time allows, I participate in some communities like OpenCV community, where I take part in some competitions from time to time as well. So hope we're gonna have some interesting presentation today. This is a short agenda. We'll talk about the operations, installation process, what it is. I will show some demos of the application that is utilizing Azure Spatial Analysis, and we'll talk about some features and limitations afterwards, and do some comparisons as well. So first of all, just one theoretical slide about what it really is. Spatial analysis is about taking the video feed from the cameras that are present in shops, for example, or on the street, and to convert this visual data to the numerical data. So we want to know how many people, how many cars are there on the street, which directions they go, and so on and so on. So this kind of analysis has a lot of benefits. We can get a lot of information about clients. We can measure traffic intensity. We can figure out where the hotspots and cold spots are, evaluate commercial value of the shop space, but also I'd also identify where the bottlenecks are, how much time the clients spend in a different sectors or different actions, like in queue or during the customer service. But there is a lot of information that we can get regarding the traffic optimization, regarding the natural movement paths and evaluation of efficiency of road signs, and so on. It's really interesting analysis. So when it comes to Azure Spatial Analysis, we have out of the box, we have 4 operations available. First operation is person count. It's basically counting the number of people in the view of the camera or in the specified region. We can define a region or regions, couple of regions within the view of the camera, like for example corridors or some space in front of cashier, for example. So another operation is a crossing polygon, also dwell time, calculation of dwell time, which is about the identification of movement within the specified polygon, which is drawn here as a blue shape. Every person that is interacting within this polygon will be counted, and we identified the direction the person is coming or direction the person is leaving, and also identify or calculate the time that was spent within this particular polygon. Another operation is line crossing, which is kind of the same as polygon, only that we can specify a specific line and basically count people coming in, coming out. And finally, there is a person distance operation, which calculates the distance between persons in order to figure out if there isn't too much congestion or there is too much crowd within certain area. We can set the alert to certain value, which will be triggered when the persons are too close or too far away also. So we can measure or alert whenever there is too much, or people are too close to each other or too far from each other. On top of that, there is also additional functionality of detecting masks. So we can calculate or figure out what percentage of people are wearing masks. Regarding technicals, in principle, the service called Azure Spatial Analysis is basically a container which encapsulates an application that ingests a video feed from the camera. This can be also pre-recorded material, not only doesn't have to be a live camera. Then the container basically analyzes this feed and returns the data. The data are being returned in JSON format, and they are fed to or streamed to Azure IoT Hub. And from IoT Hub, we can basically do whatever we want with this data. We can set some sort of functionality to create alerts, or we can stream it further to Power BI for analysis, or to database, or to our custom application that we want to process this data somehow or visualize it. As far as requirements, with live feed video from the IP camera needs to be in HD format, so high definition, 15 frames per second, and available in RTSP protocol. As I said, it could be also be pre-recorded video file for analysis. It could be MP4. And the requirement is also that we need to set up a host machine to run the IoTH container, because the container, the whole analysis, spatial analysis, works as a IoT edge device. So basically, we need to have a host to run this upon. And this container can be installed either on virtual machine. Currently, it requires some pretty much strong GPU unit, and for example, N-series virtual machines on Azure, they are equipped with Tesla T4 graphic units, which are very good for processing this kind of data. The smallest instance of this machine, NC4AS T4, costs about $330 per month right now. Another possibility is to have Azure Stackage, which is basically a service which allows you to rent a computer, a rack computer, which you can put into your own on-prem server, and use it basically without sending data to the cloud. You can also run the container on your own server, only that we need to have a fast GPU. As I said, Tesla T4, K80, or NVIDIA 1280 Ti would be the sufficient graphical processing units. When it comes to installation, we have more or less, we can follow this path. First is setting up a Linux virtual machine. As I said, doesn't have to be virtual machine, but the easiest part, the easiest process would be to run a virtual machine, which you can set up pretty quickly. Then you install a Docker container, which you download from the Azure repository. Then what you need to do is to create a manifest, which is an XML file, and it configures the operations and the cameras that you want to use during spatial analysis. And I will come back to the manifest in a second. After the manifest is deployed and the container is running, there is data collection. So the container is analyzing the video feed, processing it, and returns the data in JSON format, which can be streamed to Azure IoT Hub. And then all of those remaining blocks, which are marked in red, from here to here, are basically optional. From IoT Hub, you can direct this data whenever you want, in whatever direction you need. The typical scenario would be to use Azure Stream Analytics, for example, to aggregate this data a little bit and to direct them in a certain services, in certain directions, for example, Power BI or the database for storage. And then from this database, we can take the data and visualize it or process it, display it somehow in our custom app. Few words about the manifest. The manifest is basically an XML file which contains the definition of operations. And if you can see here, these are the operations that I've been talking about a little bit earlier. There is person count, there is person crossing polygon, person crossing line, and person distance operations. So you can run within one container, you can run up to eight operations. They could be different cameras, they could be different operations, but could be also one camera and 8 same operations. The combination is basically what you want. So what we see here is the URL for the live video feed from the IP camera. What is important to here is that you need to set up the flag to video is live true, or if you set this flag to false, here in the video URL you can give the link to Azure storage or to any storage that contains the pre-recorded file. What else is here? In this definition, you define in this manifest key, you can define the polygon, which is the area of interest that the camera is bringing to the container, and it's the values are only calculated based on this area, which means that you don't have to calculate you can actually calculate the whole frame or take into account the whole frame, but you don't have to. You can define as many polygons as you want, any shape you want, and these are relative values. So 0.0 would be top left corner of the frame, and 1.1 would be bottom right corner of the frame. So you're using a relative values to define a square or any other shape that you want. You can also calculate the trigger of the algorithm. So whenever the analysis is triggered, you can define it in a way that it could be triggered like every second, every 5th second, or every 10th second, whatever you want. Or you can also trigger it as an event, meaning that you can the analysis will be triggered whenever any change occurs. So for example, if there is 0 people and then if there is 2 people, the analysis will be triggered. You can define the operations within the manifest in a way when there is a person crossing line, you only define a line, you don't have to define polygon. So from here to here, and maybe here with the person distance, you also define the minimum distance threshold, which is interesting because you define it in feet. 6 would be more or less 2 meters, a little bit less than 2 meters, or the maximum distance threshold. So whenever those thresholds will be met, will be below 6 or above 35 feet, then the alert will be triggered. Okay, and then this was the definition of operations, and this is how the data looks when it's coming out of the algorithm. So basically this is what we receive from the container. This is just an example. We have the type of the operation, we have the camera name, which we can define in manifest. We have a zone, which we can also define by name, which would be easier for human to read. And then we have detections. We have that during this particular event, there is 2 people detected. We have 2 detections ID here. And this is the most basic operation. Also, you have some additional metadata here about the detections. And as far as the person dwell time event, we get a little bit more data here. We have a status because there was a polygon defined, and we have 1 detection, and somebody left, so exited the polygon on the side 2 of it, and it remained within this polygon for about 4.2 seconds, because this is milliseconds value, so this would be 4.2 seconds. So this is the example of the data that is returned for the person zone dwell time event, which is about the interaction of person within the polygon. yeah, and this is how more or less this is defined. This is the way it's structured. Let's move now to a demo. So okay, here we are at our demo app. This has been pre-recorded earlier, and because of privacy reasons, I cannot really show the footage from the store. But we have this video, this view from the office window, which we basically used for testing the efficiency of the algorithm. What is worth mentioning here is that this is highly unoptimal camera view for this kind of analysis. The camera is a little bit too far, should be much closer, and in fact in regular shop when you have CCTV cameras, they are usually positioned much closer to persons. And also the lighting is not optimal, it's in shadow, it's kind of blurry. Also the camera is behind the glass. But it's a kind of interesting experiment, because we were testing the efficiency, and we can evaluate the efficiency of the algorithm in a low light condition or difficult light conditions. So what we have here is at the bottom we have events which are streamed from the IoT hub, and we are capturing them within the database. And then from the database we will analyze it later, but in this view we basically have a streaming data, which is a live view. The chart here on the left bottom side is the latency. There is a latency, between the data being fed into the algorithm, and then it's gonna be returned to our application, to IoT hub, and there is a latency about this. So what we have here, we have a polygon drawn here, the yellow rectangle, almost rectangle, which we are interested in, which is our area of interest. On the right side we have 4 operations. We have person counting, we have line crossing, and we have zone analysis and distance analysis. So whenever there is a person interacting within this polygon, whenever there is an interaction with the person within this polygon, an event is fired, and we have some results here. So we can have live count of people, we have the average, we have minimum, maximum, and we can basically observe how the traffic is commencing. With the zone analysis, we can also record entrances from the north, from the south, from the west, from the east. Now we have some interesting group of people which we're gonna be identified, and we can see the results here. The algorithm cannot detect every single person in this light, and then we have unidentified enters and exits here in the bottom. And then we also have the average time spent in the zone within this yellow area. Also there is a line crossing, there is a line. Here we have some people interacting with this line, and we can see whenever the algorithm is detecting crossing of this line either to the left or to the right, and it's also recording this. You may notice that the distance analysis is not working in a way. That is because the distance analysis is a pretty much heavier operation, and because we are using single lens camera, we don't have a spatial camera here, stereo camera, that would allow us to define the distance. But using a mathematical formula, the algorithm is learning, analyzing the movement of people, analyzing the size of people, and he's gonna calibrate itself to this area of interest, to this point of view, and will start to stream results after a certain amount of time. It just simply needs to calculate a little bit and observe people for a couple of minutes. Let me scroll further, because maybe we will have some yeah. Okay, so about 14 minutes into the analysis, we are starting to have some readouts. Yeah, so here about 14 minutes after, it started to define or to figure out the distance violations and the number of violating persons, also average crowd density and average distance of between people. Whenever there is a couple coming, people coming walking together, it will be fired as a violation. As I said, this is highly unoptimal because normally the camera should be much closer to people. So this is just, you can treat it as a reference, but in general, the algorithm is working. Now this is about visualization. This is our custom-made app. What is interesting to see is the analytical part. So we have here the analytical part of the same situation, the same scene. We can import different kind of operations, events here: line crossing, zone crossing. We have person counting at the first place, and then once we collect the data, we see the some values for this particular time frame. But we can also run some more detailed analysis, like for example, average number of persons within per quarter, so per 15 minutes or per hour maybe would be more interesting. So you can see that from 11 o'clock until 4 p.m. the average number of people in this area is growing, which is natural because it's close to the town hall, close to the market square, so the traffic of people there is slowly increasing. Then, for example, we have zone analysis, which will give us some more interesting facts about this area. So we have that many enters, exits per north, east, south, and west entrance, or the side of this area. We can also make some analysis here. We can enters by time, exits by time, or maybe shares, like which side of the area is more frequently visited or entered through. Another interesting thing is that we can draw some sort of we can draw a visualization of people movement, tracking of people's movement, and we can. This is almost looks like a heat map, but it looks basically it displays how people moved within this area, and we can easily see which part of this area are more frequently visited, or where people stand more frequently, and which parts of this area is less frequently visited. So you can think about this as a shop space, so you can see exactly where people are standing longer, and which parts of the shops are, for example, avoided for some reason. Maybe the furniture is wrongly positioned, or maybe there is some sort of problem with the traffic corridor. So you can see, you can get some interesting insights from this data. Also zone dwell time, which calculates or displays how much time people spend more or less within this area. We can also see that the average dwell time starts from 6.7 seconds of people walking through this area. Then maximum was about 2 o'clock, where people spent about 16 seconds, and then also going down to 6.7 seconds in the afternoon. We can also get this much better, much more detailed insights. Like for example, somebody was standing here obviously for 3 minutes, could be like this. And we can get some interesting insights of how people react, how people behave in this particular region. So this is an example of application that you can utilize or develop yourself, but I think easier solution would be to get the data from database and analyze it within the Power BI, which would be much faster to create all kinds of all kinds of insights, all kinds of dashboards, all kinds of reports that you want to see or look or analyze within your particular scenario. So what we found out from using this service, Azure Spatial Analysis, it's very fast to deploy. You can virtually deploy it within 1 or 2 days maximum, including the calibration of the cameras, unless of course you have access to all needed hardware. There's no hardware needed except for cameras, and even the cameras are not needed if you want to analyze the pre-recorded material. This is definitely a low-code solution. You just need to do a little bit of coding for the manifest file that I showed before, and a little bit coding with Azure Stream Analytics if you need it. And otherwise, it requires some knowledge of definition and using the Docker container. But otherwise, there is no programming needed. The model itself, the people detection model or vehicle detection model, because there is actually two detection models available, one for vehicles and one for person, is strictly maintained by Microsoft. They release new versions, improved versions periodically. So from time to time you can get an upgrade if you want. You don't have to upgrade, but if your model is working fine, then you can stick with the version that you like. There is some limitations, of course. Strictly defined functionality, you can have only those operations that I mentioned, people counting, line crossing, and so on. Maximum 8 operations per GPU unit. So if you have many cameras in your shop and you want to analyze larger space, you need to deploy more units, more GPU units. It's pretty much compute heavy. Also, different operations they require different computational power. Like person counting is more lightweight, and the distance counting is more compute heavy. So depending on what exactly you need on your scenario, you may want to use more GPUs or less. Depends what you want to achieve, what data you want to get. And it doesn't really work out of the box. It requires more cloud services to operate. You need to have at least IoT hub, and then basically stream this data in a direction that you require. Nevertheless, it's a very good solution for most scenarios where implementation time is crucial and existing cameras are available to connect, or you have some pre-recorded footage that you want to use. Our problem was that we wanted to have a re-identification of person. So what is worth mentioning is that the Azure Spatial Analysis, it doesn't identify people at all. It's made on purpose. Microsoft is very careful about ethical AI, and it doesn't want to use any of these services to create any kind of privacy concerns. So Azure Spatial Analysis doesn't detect and identify people as they are. So there is not possible, for example, to detect faces or detect the identity of person, which creates a little bit of a problem if you want to have a scenario where you want to see if the client has returned after a while to your shop, or if it visits your shop or visits some place regularly. This is not possible because every detection ID is basically unique. We needed to look for the alternative. So another solution to spatial analysis, another approach to spatial analysis is we can use a specialized hardware, and in this case we have Luxoni's Oak Delight camera, which is a very nice, very small, lightweight camera that you can position anywhere. As you can see, it's equipped with 3 lenses. One on the right, one on the left is stereo lenses, which allows the camera to see the distance or to measure the distance. And one in the middle is RGB regular lens you can use for preview or to run some other functionalities. This camera is basically a computer capable of running models, AI models, right on the chip. So you can upload the model, you can do some programming on the device, and it will return the data that you basically need. And what you can do with this camera is virtually everything. You can do people detection, you can do image segmentation, you can do whatever scenario you have. Then you can basically facilitate with this camera. It's pretty cheap and it's USB powered. The main benefits is that you can run any ML AI model on it, and the computations are performed on camera. So you don't have to stream the video data to the cloud for processing and then receive the numerical data back. You simply make a computation on the device itself, and you can receive the data, the ready numerical data right out of it. So you don't really have any need for cloud infrastructure. This device gives you a lot of flexibility to create any functionality that you want. So let me show you a quick demo that we did just using this camera. For the sake of simplicity, the camera is operating on 1 frame per second, so we are not analyzing every single frame, although this is also possible, but we are analyzing 1 frame per second. And you can see that we have also established a frame within a frame, the area within a frame, the white rectangle, that we are counting the people inside this box. So we have two numbers, two values. One is all the persons that are detected in a camera view. Some of the people in a very, very high distance, they are not detected as persons, but in general you can see that the algorithm is doing a good job detecting people. And then the green number is the number of persons detected within or interacting within this defined area. So this is another solution. You can virtually replicate all the same operations that are available in Azure Spatial Analysis, only that you just need to do some programming about this. But in return, you can also position this camera, because they are very light, they are very, very small and easy to use. You can virtually put these cameras anywhere. Connect them with USB to the host machine and get the information from places where maybe CCTV cameras are not available. So this is another approach, and it's definitely worth considering, especially when your scenario, where your situation is not so typical. So coming back to the presentation for the last slide, it's just a quick comparison of Azure Spatial Analysis and OAK Lite. So this is the comparison of two approaches, so to speak. I spoke most of, all of those differences I mentioned within my presentation. What is worth mentioning maybe is that again, no personal identification is possible in Azure Spatial Analysis. However, this can be done within OAK Lite environment. You can program the camera in a way that it detects the face of the person, and then it will remember this person as an identity. And then when this person returns, later on, an hour or maybe another day, it can compare it to the index of identities that it was detected, and then it can really re-identify the person as a returning customer. So this is possible to do for OAK Lite. And some final remarks. As I said, Microsoft is very strict on ethical AI, so video feeds are not saved in the cloud. They are sent to the cloud just for the processing purposes, and then they are deleted. It's data only service, so you only receive the numerical data back. And I think the edge computing, which is the example of this scenario with Oak Delight, it's very, very interesting to consider, especially considering the amount of data, video data that you need to send out to the cloud, and to consider the bandwidth capacity that you need to facilitate and you need to consider. Also the storage. So the edge computing, where the calculations are made on the device, and then you only receive the light JSON file data. It's really something worth considering when you design scenarios like this. And about the next steps that we want to make is definitely a Power BI connection for advanced reporting. The Power BI reporting are much more flexible, and you can do really a lot and much quicker than designing your own application. And what is interesting also to consider is to create some model that analyzes the track of people, how they move within the store, to consider some anomaly detection models, and for example to detect some persons that are behaving differently, for example preventing theft, and so on. So these are the directions that we want to move within the next weeks and months. So thank you very much for watching. I hope you found this presentation interesting. Please feel free to rate the presentation. I always want to hear from you and to be better. And if you want to know more or contact me in a way regarding what you just saw or some other related questions, then there is some contact information here on the slide. Thank you so much. Hope to see you soon.